is 5.68 grams of the stuff. So how are we going to make the solution? And I'm sure that when you're in the lab, they'll tell you much more about this and tell you how to make it, but let's just go through it. Here's the calculation though. So I'll just put that up there to remind myself. So what happens is that the first thing is that you have to go ahead and weigh out solid solute. After all, this is the kind of problem that we have. And you have to weigh out, we said, 5.68 grams of sodium sulfate. So I'm going to put a little weigh boat there, and then I'm going to put the sodium sulfate in there. Now the next thing we have to do is we have to worry about taking the solid and getting it to be a solution. So the next thing you want to do is get 100 ml, 100 ml is how much we want to make, volumetric flask. And as you've already seen my little pictures before, I'm going to draw that like this. And that little line there is going to be the 100 ml mark. That's what the flask is designed to measure. And then what you're going to do is you're going to take this sodium sulfate and you're going to put it into the flask. So transfer the solid sodium sulfate to the volumetric flask. And of course, and you'll figure this out and it'll be demonstrated for you, but it'll stick all over the place. But we need to get all of it. This is a quantitative transfer, meaning we need to have all that solute that you measured out in that solution. So you'll use DI water to rinse any solute that's sticking anywhere, whether it's in the weigh boat or the neck of the flask, into the flask for the solution. And then what you're going to do is add DI water until the flask is halfway full. So it'll look something like this. And the reason you want to do that is you don't want to fill it all the way up because you've got to do some swirling to dissolve. If you brought it all the way up, you would really have a hard time getting it dissolved because there wouldn't be any room in there to sort of swirl and agitate it. And then once that's dissolved, what you want to do is add DI water to this line that's right up here, and that line is calibrated to give you exactly 100 mils of a solution. So you add the DI water to the line, and you want to make sure, of course, that if here's the line, that the meniscus of your solution sits right on that line. If you go too far, well, then you have to start over again. So it'd be best that when you approach this line, you use some small pipette or eyedropper to add things one drop at a time. So you add it to the line and invert, let's say 5 times to mix. And before you invert, you probably should cap it, or else you'll have it all over the place. And again, this will be talked about in lab. So in the end, you're going to end up with a solution that's right to the line. And this is my way of representing the fact that you have dissolved solute in there. So I've shown you this kind of problem, making solution from a solid solute. We talked about how to calculate it. And we also talked about how to make it. Both of those things are things you'll do in the lab. Now there's another way to make a solution, and it actually ends up being an easier way because weighing is something that takes a lot of time. So the second way of making a solution is from a more concentrated solution. And we often refer to that solution as a stock. So let me give you an example of this so you can get a context before we go ahead and solve the problem. So here's my example. Let's say I want you to make, again, 100 mils, because we have 100 mil volumetric sitting out in the lab, 100 mils of a 0.0100 molar sodium sulfate again. Using the 0.400 molar sodium sulfate solution you prepared, or we pretended to prepare, in part 1. So you see what happened? I just pretended that we made the 0.4, this part before. This is the 0.4 molar sodium sulfate, and now we're going to use this as our stock, our more concentrated solution, to go ahead and make a less concentrated solution. So before we get into the calculation, let's just talk about how that might go. So let me draw it again for you. This is supposed to be the solution we just prepared. So it's a 0.400 molar sodium sulfate solution. It'll be our stock. And what we'll do is we'll pull some of that out. We'll pour some out, let's say, into a graduated cylinder. We'll remove it and measure it. Okay, so we don't know how much we're going to take out, but we'll measure that, and then we'll take that graduated cylinder and we'll pour it into a new 100 mil volumetric. I'll try to draw this. You'll have to excuse the fact that I'm not that great of a drawer, as you know. I guess that doesn't stop me though, huh? So here it comes. It's going to go in there. So we'll pour that amount into the volumetric flask. Then we'll end up having the volumetric flask having that solution in there. And again, that's I'm labeling that as question mark because we don't know what it is yet, but soon we'll put a letter in there to represent it. And then what's going to happen, once you transfer that stock, some of it measured out, into the flask and you've got it, then what you're going to do is add water, DI water, and you're going to bring that up to volume. So now you had that much, now you're going to bring it up to volume with water up to the line, and you will end up with a more dilute solution. So this is the stock solution, or the concentrated one. This will be the dilute solution. And in this case, remember the problem, we're hoping that this one is 0.100 molar sodium sulfate, whereas this one over here was 0.4. So you get the idea. We're taking it out, we're putting it in, we're bringing it up with water, and now we make a more dilute solution. Okay, so how the question mark I've kept using is really the unknown, right? We know how much we want to make of the dilute solution. We know what concentration we want it to be of. Here's the volume of the dilute solution. We know the concentration, and we'll call this concentration of the dilute. We know the concentration of the stock, right? So concentration stock, concentration of the dilute, volume of the dilute. But what we don't know, and what we have the question marks around all the time, is we don't know how much you're supposed to take out of the stock to use to make the dilute. And that amount, that question mark, we're going to call that the volume of the stock. Now watch, it's not the volume of the stock you start with. That was maybe 100 mils. It's the volume of the stock you remove from the stock to make the dilute. So these two volumes are actually quite different. The volume of the dilute is the volume you want to make. And this volume here, the volume that you're removing, we're calling that VS, and that's the volume you want to take. From the stock. And in case you didn't get the fact that that rhymes, volume you want to make and the volume you want to take, well, let me point that out to you. Okay, so how are we going to calculate this amount? Well, we're going to make use of a formula that goes like this. VS, which is the CS, which is the concentration of the stock, times VS, which is that amount you take from the stock, will equal the concentration of the dilute times the volume of the dilute. And this, of course, is the volume you want to make. So in this problem, we have all of our variables except we don't have the volume that you want to take. So let's solve for that. I'm going to get this variable over on that side, so I'll end up with volume from the stock equals the concentration of the dilute solution times the volume of the dilute solution divided by the concentration of the stock. And let's substitute in. The concentration of the dilute solution is 0.100 molar, or moles per liter. The volume of the dilute is 100. And the concentration of the stock is 0.400 big M. And if you do this math, you come up with 25.0 mils. Now that's the amount you want to take. So what you'll be doing, I'm back up here now, is you'll have your stock from the previous problem, and this isn't exactly the problem you'll be doing, this is just an example. You'll take out 25 mils or whatever it is you figure out. You pour that into the volumetric flask and then bring it up with water. And even though it sounds kind of weird to be making one solution from another solution, you'll find that this is actually much easier than having to weigh out an exact amount of whatever your solute is. Okay, so I hope that this little movie is useful in preparing you to do the lab. Everybody needs to do the pre-lab based on this little lecture. So good luck, and let me know if you have a problem. Okay, bye.